Hey everybody, I hope that you are having a good evening. Here is your video for tonight. We're going to go back over logarithms. Logarithms and their functions. Now once again, our basic form for a logarithm that has a base b, and then we have x equals y. Then to put that in exponential form, we are going to use b to the power of y equals x. B to the power of y equals x. And so it kind of makes a circle. First you go b to the y and then back to the x. We're going to use this to look at a few more relationships. We were working some of these in class, and then we're going to talk about our logarithm functions and graphing those as well. So if we want to evaluate these situations right here, if we set this equal to x, then we are going to say 4 to the x equals 1/64. 4 to the x equals 1/64. Well, you know that it's going to have to be negative because it's going from a 4 in the numerator to the denominator, and 64 is going to be 4 to the third. So our x is actually going to equal -3. Now if you want to check, go ahead and plug 4 and then use your to the button, -3 in your calculator. You're going to get a crazy decimal, but when you hit math and change it back to a fraction, you should get 1/64. Now, looking at our next relationship, 5 to the, we're looking for the power, what power equals 1/625. If you're not sure, you know that it's going to be a negative, but we got to know what 5 times what gives me 625. So is it 5 squared is 25, 5 to the third is 125. This is actually going to be 5 to the fourth, and so x is going to be -4 since we need it to go to the denominator. Here we have 8, and we're looking for that exponent again. It equals the exponent. 8 to the x equals 512. If we go in our normal pattern, 8 to the x equals 512, it's going to be positive because we don't have any fractions involved. And 8 times 8 is 64, but if you multiply again by 8, then that gives you the 512. So our x is actually going to be equal to 3. And then our last relationship, if we have 27 to the x power equals 1/3, we know it's going to the denominator, and so it's going to have to be negative. And the number is actually going from 27 to 3. So that's going to be a root. So it's going to be -1/3. The third root of 27 is going to give us 3. If you want to check, pause this video and you can put it in your calculator. If we have 27, just make sure when you put it in your calculator with the to the key that you put parentheses around that -1 divided by 3. Right. Now, I said that when I thought of how am I going to graph a logarithmic function, my brain immediately goes to exponential. My brain wants to use that relationship. And so if we know we have some basic relationships, the parent functions that you can memorize if you want to memorize those points, or if you're like me and you like the exponential, then you can go that route. So let's start with something easy. What happens if I want to graph y equals the log, I don't know, let's do base 4 of x. If I want to do y equals log base 4 of x, then this is my logarithmic function. In order to find my exponential, I'm going to do 4 to the x And so the 3 points that I like are -1, 0, and 1. If I plug in a -1, that's going to give me a 1/4. If I plug in a 0, that's going to give me a 1. And if I plug in a 1, that's going to give me a 4. This is all exponential. To find the logarithmic, I actually have to do the inverse of the exponential. So that's going to give me 1/4, -1, 1, 0, and 4, 1. 1/4, -1 is going to be here. 1, 0, and 4, 1. So we're looking in this particular relationship. If you want to put this in your calculator, there are some of you who have an 84 plus that actually has the option to do logarithmic, but our calculator only does log base 10. So we're going to use a change of base formula. We are actually going to put in our calculator y equals log of x divided by log of 4. Now, if I remember correctly, you need to make sure you close out those parentheses or else you will not see the same graph. And if you look at your table, you're not going to see that 1/4 because we're set up on integers, but you definitely can check to see that you have the 1, 0 and the 4, 1. We haven't done one where we had a number that was in between 0 and 1, so quickly I want to look at that situation. If I give you y equals the log of 1/2 x. So that is going to give me a situation. I'm going to use a different color. If I want that's going to give me 1/2 to the x. Y equals 1/2 to the x if I do exponential. And so if I plug in -1, 0, 1, if I plug in a -1, ladies and gentlemen, then that negative does the reciprocal of that fraction. It brings the 2 up if I distribute it. And I'm sorry, 1 to the -1, 2 to the -1. And then that's going to give me 2 over 1, or just 2. If I have something, we are going to have 2 as our answer. Anything to the 0 power is 1. And anything to the first power is going to give me 1/2. This is my exponential. I'm sorry, I'm going to pause for a second. Sorry about that, guys. I'm not feeling real well today. Alright, so if I then find my inverse, then I would have 2, -1, 1, 0, and 1/2 1. So 2, -1 is going to be here. Our 1, 0 is going to be here. And our 1/2 1. So it actually is going to be going in this direction. If you wanted to put this in your calculator, you are going to have to do y equals the log of 1 divided by 2 divided by the log. Oh, sorry, I did that wrong. It's going to be the log of x divided by the log of the base, 1 divided by 2. And because I want to make sure, some of you might use a 0.5 instead of the 1/2, but this is what we're looking like. So we are correct. Now the last thing that I'm going to do tonight, because I am about out of a voice, we are going to talk about our shifts. So if we have f of x equals a times the log base b of x minus h plus k, then we are back to Old Faithful, guys. We have horizontal, this is going to be our horizontal shift. we have it is subtract. We are going to be moving to the right, and negative moves us to the left. If we have a plus k, this out here is going to be our vertical shift. If we have a negative in the front, if a negative is added, if a is negative, then we reflect over the x-axis. And then we also have the relationship with our a. Let's do purple. If we have an a, if the absolute value of a is greater than 1, they describe it as expanded vertically. And if the absolute value of a is going to be in between 0 and 1, then that graph is compressed vertically. We'll look at some more of these problems tomorrow. I hope you guys have a great night.